Hello learners, and welcome to today's lesson of multiplication and division of polynomials, where we are going to be focusing on the practice and application questions. So let's get started. Let's look at the following expressions, and we are required to now simplify these expressions. Now remember all that you've learned about multiplying monomials that are constant, monomials that are non-constant, when we are multiplying them with binomials and trinomials. So this is what we need to keep in mind during today's lesson. So for number 1 there, we have 1/3 multiplied by 7y squared. So 1/3, remember now, because we have a constant, we are going to multiply it with the integer, and then the variables are just going to stay as they are. So what is 1/3 multiplied by 7? This is simply going to give us 7/3 as our answer, and the variable will remain as it is. Now, because we need to simplify that as it is an improper fraction, 7/3 is equal to, remember how we break them up, we are going to say 6/3 plus 1/3, and that y squared remains as it is. And how much is 6/3? This is 2, and that is going to be 2 and 1/3 with the y squared. Let's look at number 2. We have a -20 there multiplied by a 4z. So again, what are we going to do? We are multiplying the integers. Now take note there, we are multiplying a negative number with a positive number. -20 multiplied by a positive 4 is going to give us a negative answer, and that answer is going to be -80. And the variable stays the way it is, so our answer there is going to be -80z. Let's look at more questions. Now for number 3 there, we are still simplifying the expressions. I have there 9gh multiplied by 5h exponent 6. Now look at how we have more than one variable this time. So what is supposed to happen? We are multiplying a non-constant monomial with a monomial. So we are going to start by first multiplying the integers. That is a +9 multiplied by a +5. And a +9 multiplied by a +5, that is a +45. Now, we have g as a variable, so we are going to go look at the monomial that we are multiplying with to see if there is another g. Why are we doing this? Because if we have powers of the same base, then we can add the exponents. So we are trying to look for a base that is the same as g. As I am looking there, there is no other g, so that g will remain the way it is. Then we move on to the h. And when we look at our non-constant monomial that we are multiplying by and our monomial, now we have an h on both of them. So the same base, we are going to add the exponents. That means that h is going to have an exponent 7. So my final answer being there, 45gh exponent 7. Let's move on to number 4. We have there 10k exponent 4 multiplied by 1/3k, or 1 divided by 3k. So how are we going to multiply that? Let us start with the numbers. We are going to say 10 multiplied by 1/3. So what is 10 multiplied by 1/3? That is 10/3. And then we are going to have there, so we still have the k exponent 4 as the numerator, and we still have the k, and we know that that k has an exponent 1 as a denominator. So now I have to apply my laws. I have to simplify the fraction, and I have to apply my laws there. So let's start with the laws there. When we are looking at the k's there, we have a k exponent 4 divided by k exponent 1. What is going to happen to those exponents? I am going to subtract them. So that is going to be 4 minus 1, leaving us with k exponent 3. And then now when we focus on the 10/3, so how much is 10/3? We know that 10/3 comes from 9/3 plus 1/3. third. That's one way that we can separate that. We still have the k cubed outside of that bracket, but 9/3 is equals to 3. And when we add that 1/3, it's going to be 3 and 1/3 k exponent 3, or k cubed. Number 5, we have there a non-constant monomial multiplied by a binomial. So we are going to remember that distributive property, because this number outside is going to be distributed with each of the terms inside the bracket. So we are going to multiply. So let's start with that first term of the bracket. We have 4 multiplied by a negative 6. Now we are multiplying a positive number with a negative number. So that is going to give us a negative answer. 4 multiplied by a negative 6 is negative 24. Then we look at the variables. They have the same base. So if they have the same base and we are multiplying, what happens to the exponents? We are going to add them. So that is going to be a negative 24f, and my exponent is going to be an exponent 8, because 5 plus 3 is 8. Then we are adding, and then we go back to the number that is outside of the bracket. Now we are multiplying it with the second term there. So that is going to be 4 multiplied by 3, that is 12. Then again, we do have variables of the same base, that is f exponent 5 multiplied by f exponent 1. Same base, we are going to add the exponents. That is going to be f exponent 6. So my final answer there is negative 24f exponent 8 plus 12f exponent 6. Let's move on to number 6. So we have there 3k squared, and in my brackets I have 10k minus 4. So we are still going to use our distributive property. So that is going to be 3 multiplied by 10, that is 30. And then we have k squared multiplied by k, that is going to be your k cubed. Why? Because the same base, we add the exponents. Then we are subtracting. We are going to say now 3 multiplied by 4, that is 12. And since there are no variables in the one that we are multiplying by, then we are just going to keep that variable there, and that is the k squared. Let's move on to the last two from our practice section. So we have there 21m squared minus 7m, and they are all divided by the 7. So now we're having a binomial that's being divided by a constant monomial. So what is going to happen here? Remember that denominator 7, or the divisor, it does belong to the 21m squared and to the 7m. So this means that we have here 21m squared divided by 7 minus 7m divided by 7. And as an answer there, we are going to divide the integers but leave the variables as they are. So that is going to be 21 divided by 7, that is 3m squared, minus, and then we have 7 divided by 7, which is 1m. And that is our final answer. Let's go on to number 8. We are going to say here, or we have there, 4n minus 6m minus 14. And all of these are divided by a negative 2. So we have here a trinomial that is being divided by a constant monomial. So what is going to be our answer here? Let us start by giving each term its own divisor. So we have 4n divided by negative 2 minus 6m divided by negative 2 minus 14 divided by negative 2. Now, what is 4, a positive 4, divided by a negative 2? Because remember, we are going to divide the integers and then leave the variables as they are. So what is 4 divided by a negative 2? That is a negative 2n. Then we have a positive 6 divided by a negative 2. So a positive 6 divided by a negative 2 does give us a negative answer, and that is a negative 3m, right? And then that is going to be a 14, which is a positive 14, divided by a negative 2, that is going to give us a negative 7. But remember, if we are subtracting a negative number, then the result there, it's the same as adding its additive inverse. So this is actually going to be now negative 2n plus 3m plus 7. And that is going to be our final answer. Let's quickly go to an ad break so we can come back and look at those application questions.